In this video, we're going to cover meshing principles and fixing meshing errors as they relate to the RCB software. We won't go into the same level of detail as the SLB meshing principles and fixing meshing errors videos, and we assume that the principles discussed in those videos are understood. So basically, we're just going to be building on those principles in this video as they relate to RCB. So we're going to continue working on the file from the previous video, the file where we imported all the CAD files. So in summary, what we did was we just simply imported the CAD information, looking at the building in 3D. So we can see we have a structure in there, but for whatever reason it is incomplete. Some of the floor plates aren't generated correctly. So this video, we're not going to input any thicknesses loading at all. We're just going to clean up the geometry so that it meshes without any errors. So let's just jump in straight away and generate the mesh, and let's have a look. So we receive an accuracy warning, and we'll just hit continue. What that is there's probably many decimal places that have been imported from the CAD file. So when this finishes, we'll see that the degree of accuracy needed in the CAD file can sometimes be very high. So to get these curved shapes, for example, drawn, it has to use a high degree of accuracy. So for our structural models, in the INDUCTA software, we can model free geometry, but as we'll see, it is not always the best idea, and we don't recommend it, hence why we show these warning messages. And that's almost done, and we'll see a summary at the end of the meshing. We probably have some meshing errors as well. So we see we have a bunch of closed node errors. So I'll very quickly go over the meshing principles again. Let's go to a floor that had a few of those errors. So if we just want to see that previous window again, the report, we go to reports and to the log file. So level 3 had many errors. Let's just have a look at level 3. There's a bunch of them there. So the meshing principles, very quickly what they are. Similar to the SLB software, the program automatically generates the mesh based on some predefined rules. So we use a triangular element, and it automatically generates to the center point of columns. It automatically generates to the center length of the walls and beams as well, which we haven't modeled in this case, and also to the geometry lines and geometry line nodes. Now, based on, we select a predefined mesh size, so in this case 1 meter, but it doesn't mean that the software can't squeeze the mesh into gaps smaller than 1 meter. So for example, we see here we have the wall center line, we have the lift shaft drawn exactly where it will be in reality. The program is able to squeeze in mesh to the center line of these, to basically squeeze it in between the gap between the center line of the wall and the lift shaft. Now if we go up to the level with many errors, level 3 for example, these circles indicate closed node errors, meaning that the program was not able to mesh to these various elements above and below without having errors. So it was not able to generate the finite element mesh, meaning that the results at these points will be inaccurate. So ideally we should fix all of these errors before we continue any modeling or continue any results. This many errors will probably cause the analysis to crash as well. So the principles of meshing are the same between all INDUCTA programs. The only difference is the RCB software has the added complexity of meshing to elements above and below. So if we go to a transfer floor here, we see that we generate mesh to the center line of the walls below, which we can't select, and the center line of the walls above. Similarly with the columns running above below. So the columns, they are important, but we're not too fussed about them because they're relatively simple. They're just simply a point support. In the RCB software, it's the walls that are the critical elements. Why they're the critical elements is they're more complex. They're longer, and there's also more chance that they will cause the analysis to crash. They're a much more complex element internally within the software as well. So what we see here is the finite element mesh generated in the slab, so on top of the wall, and if we go one floor up. So on the bottom of the wall and on the top of the wall. But at runtime, the software will also generate mesh along the wall's height as well. So for example, for these walls, if we have a huge number of closed node errors along the wall's length at the top or the bottom, it will definitely crash during runtime when it tries to generate mesh along the wall's height. So we should fix this up now to avoid any potential errors further down the track when we run our analysis. Why there are probably so many closed node errors? Again, going back to the comment about accuracy, we see that a high degree of accuracy has been imported in some elements from the CAD file. That is probably what is needed to draw these elements in their exact position as they will be in reality. However, this level of accuracy is not needed for the structural model. So we can go down to a much lower level of accuracy and still capture the structure's true behavior. So the very first thing, the rule of thumb in all of the INDUCTA software is get your information in from CAD and round off the geometry. So that is done under Tools, Round Off. Now, many users are thinking, okay, this is the preliminary design stage, the first model that we run. What happens if I have to re-import CAD? Now, we do handle this. We can round off selected elements at a later date. So for example, if we just have to change the layout of one floor, we can round off selected elements. This will not be covered in this video, but this is covered in the SLB Fix Mesh Errors video. So if the user wants to see how to do that, please refer to that video. So all of the CAD information is in, and we're going to, the very first thing we want to do is to round off the geometry. As we're also in the preliminary design stage, we want the mesh to run a little bit quicker, so maybe we might just make a bigger mesh size when we mesh, and we also want to switch off this default setting that automatically refines the mesh along the walls. So in order to get more accurate results in the walls, we make the mesh a bit finer, a bit closer spaced along the wall's length, as we can see. But not necessary during this prelim stage, so we'll just switch that off. So that's under Settings, Models and Solvers, and we switch off Refined Walls Mesh for transfer floors. And we could also switch it on for all walls, but in this case it wasn't. So we will keep it off for the time being, so the model runs a little bit quicker. Hitting OK. Okay, next we round off. We go to Tools, Round Off Geometry, and we'll round off everything to the nearest 100 millimeters. And mesh again. Let's just make it. Let's go to 1.5 meter mesh to make it run a little bit faster. So by this rounding off action, we should see a lot of these errors disappear because our building is in the orthogonal. Please be aware that if parts of the building are in the diagonal, this rounding off process may introduce many meshing errors. Again, this is expected. It will have to be cleaned up manually. Many users avoid rounding off specifically for that reason, but again, these few videos will show you how to handle that, how to fix that. But we should always round off so that when it comes time to analyze the building, we don't have any analysis errors. So we see there's much less than before, but still some exist. So we don't want to abort round off changes. We hit no. We will save. And we'll start by cleaning up the floors, going from the bottom level up. So now I'm going to go ahead and tidy up this model, adjusting geometry lines, walls, columns, etc. to get it meshing without any errors. So basically I'll just be talking for the bottom few floors, and basically that's where I'll discuss all of the key principles, and then I'll continue on the upper floors, but without talking. So if you don't want to watch the rest of this long video, you don't necessarily have to after a certain point, after I discuss all the principles. So the best way is to start from the bottom and work your way up. and start by tidying up the various elements. Again, the common theme, the thing I'll repeat many times, is that walls are the critical element. So what we want to do specifically for walls, if we fix a wall up on a lower floor, we don't basically, then we align elements on the floors above to it. So we fix it on one floor, align it on the floors above so that we don't have to repeat work. Now the basement floor should be relatively simple to clean up because there's no slabs here. But let's just zoom into these corners. We can see that everything's rounded off nicely, but we have a slight overrun. So the wall elements for us are centerline elements. So if we change the snap mode to snap to corner, ideally they should be touching center to center as so. And I'll just repeat that on all corners. These corners should be touching the exact same location. And yes, so the perimeter is fixed. Now we have an issue here. As we can see, if we select this wall, we see its centerline, the wall's running diagonally, and this wall is now no longer touching its center. So on the floor above, we will definitely have a closed node error here. So previously, when we imported from CAD, this was probably at its exact correct the exact intersection, but as we rounded off, we lost that information. So option 1 would be to simply use the extend with mouse and clip tool and get it touching at that exact location. However, we do have to introduce a high degree of accuracy again. So this is one option. We could keep it like this, but we just have to keep in mind that if we were to ever round off the job, so for example, not having anything selected, going tools, round off, we would lose this information again and reintroduce a meshing error. As this is basically a not so critical area, this wall is just below ground, a pile wall, for example. A better way might be to, if we hit Ctrl Z to undo, pull this wall back to the intersection and then simply draw another wall from here to here. So we've basically sacrificed the accuracy. This is obviously slightly different to what will be built on site, but we now have everything to one decimal place, and there will definitely be no issues here with the meshing or the analysis. Now let's go through and have a quick visual inspection of these other walls. So just pulling these walls back to the center lines. These should be touching on the center lines. Now let's see what's going on here. This wall, we can keep it as it is. For simplicity, let's just pull it to the corner here. So again, sacrificing the true accuracy to basically get the model running smoothly. Again, at the end of the day, it's not going to affect our results in a big way. So basically, this is the basement 4 floor done. Now let's go up one floor, and we see that all of the walls above, below match. We've already fixed them on the lower floor, so rather than repeating the work from the lower floor, let's just copy them up exactly. One more thing I forgot to mention before we do copy up. The software doesn't like basically wall elements that are very, very long. So typically the wall length should be about 15 to 20 meters. Anything bigger than that, it may crash during runtime. So we should split these longer walls up. So this wall, 30 meters, we will split it into 2 segments. So how we do that, right click, split wall into segments 2. And this one, let's just go 3 segments. 3. Okay. So we see the individual segments are now complete. This is 26 meters. Let's split this into 2 segments. This one, well, that should be all right. We'll leave that as it is. So going to this upper floor, we're going to be replacing all of the wall elements with the walls below. So let's delete these ones by going to select by type walls, all walls, and just hitting delete on the keyboard. We'll go down to the lower floor. Let's just switch off our columns. Net select, edit, copy to another floor, and we'll put it onto the B3 floor. So all of the walls now have been imported into this floor. What we have to do on this floor as well is fix up the geometry lines as they've been modeled. So we have this nice perimeter geometry line wrapping around the perimeter of the slab. However, it's drawn to the outside face of the walls. Maybe that's how it will be in reality. But for simplicity, we should have it snapped to the center line of the walls. So we just simply drag and drop. And drop it to the center line of the wall elements that have been modeled. Now note that I had to add a node here so that the angle of that geometry line matches the angle of the wall exactly, and we have that straight segment here as well. The lift and stair shafts, I'll just move the geometry lines so that they sit on the center lines of the walls, just to make the mesh run a bit smoother and faster. Same with this corridor area, just snap everything to the center lines just for simplicity. Now we don't have no reference point here, so I'll just do the set as master, align to the Y, and then I'll use this point, set as master, align to the X. And I'll just continue tidying up the remainder of these geometry lines. So this particular wall, it could be a bit neater. Looks like I forgot to fix that on the lower floors, so I'll just tidy this up, having everything snapped to one point rather than having several points, and just again fixing it up on the upper floor. And the stair shaft snap to the center lines. So now this is all nice and neat. In this area, geometry lines are all snapped to the center lines of the walls, which is good. Next, we'll fix up this area where there will probably be a most likely be a car park ramp, or there is a ramp here. So it's come in as basically one solid piece. We have to model the discontinuity in this slab, which we'll do manually. So I'll firstly snap these to the edge of the wall. Again, I could snap this to the edge of this geometry line, introduce a high degree of accuracy, but I just want to keep things simple. So what I'll do is I'll snap this to this corner, remove this node, set this as a master, and align to the Y. Then I will extend with mouse and clip. Similarly with this line as well. We don't even need this node, because we will use these geometry lines to create that flooded area. So that area should be tidy. We'll just straighten this line out. And luckily it looks like these points sort of match the intersection of the wall that we created, so that should all be good there. Now next I'll just talk about these geometry lines intersecting the this diagonal area. basically the way they've been modeled now is correct. Well, it won't cause any issues because that flooded area will be created correctly. Now, note that we don't need to have sort of similarly how we did this corridor area, this internal area here in the lift shaft. We don't have to have a closed form polyline to generate a flooded area within the slab. The key requirements generally are just one polyline wrapping around the entire perimeter, one closed one, but the internal areas such as here where this ramp will be, this just needs to be, it can be even made of individual line elements. As long as these elements sort of intersect or touch each other, the program will recognize this as a flooded area. So we don't need to basically have one closed form polyline in this area, for example. So if we really wanted to tidy this geometry line up, we could simply just do the extend with mouse and clip and clip it back to the intersection. In this case, luckily, it has gone back to 1 decimal place. Similarly here, we've had to introduce a high degree of accuracy. So rather than, one option would be to split this wall up at that intersection point, or maybe I'll just leave it as it is for now. If it causes any issues, I can come back and address it, but it should be fine because it's at this exact intersection location. Again, it's a geometry line. It will only generate, basically it's only affecting mesh on this floor. We have introduced a node with a high degree of accuracy in this wall, but it's just one, so it should be fine. And the final thing that we need to do on this floor is just to put a discontinuity in this slab at the car park ramp. So I'll just draw in some geometry line somewhere. So we'll put snap to grid on with orthogonal. I'll just go from here to here. And then I'll copy this down by some distance. And then I will use the stitch clip tool to clip it back, or the shortcut Z. So we've got some discontinuity in the slab here to model the ramp. We can't model the slope slab, for example, but this floor should now be good. Basement 2 was a slave of basement 3, so any changes we made to the geometry on the floor below has automatically been done on the basement 2 level. Going up to the next floor, we have to basically do the same thing again. We can't copy all the walls up because there's some changes, so we'll just go through and do it manually. So for simplicity, I will switch off the slabs on the current floor, the slabs below, while I fix up the walls. So the first thing that we did was snap to the corners of the walls below. We do that around the entire perimeter. This orthogonal one should be good. We just fix that edge up. This wall needed to be split, so we just pull it back to this location and then draw another wall there. This wall was split into 2 segments, so if we just do split into segments 2, we should see that because the length is exactly the same, it starts and stops at the same location as the one below. Similarly for this one, split into 2 segments, and this one as well. This one was 3 segments. So again, important thing to note, that starting and stopping point is at the same location, so there's no slight offset, so there'll be no meshing errors there. We'll just manually go through and fix up these walls in the lift and stair shaft just so that they match above and below, so that there are no meshing errors there. This all looks okay, and we'll just pull this back so the center line touches correctly. So the walls now are done, columns are looking good. We'll switch on the slabs above and below again, and we'll just repeat the process we did on the lower floor for the perimeter geometry line. So this is basically the same. We could delete this one and copy it up from the floor below if desired, but I'll just go through and fix this up. And we insert a node here, so right click, insert node, drag and drop. And these geometry lines we were doing extend with mouse and clip. And one thing to note, we can snap to the geometry lines of the elements below. So I'll just go through now and just start tidying up the remainder of these geometry lines. So this is coming as a single closed form polyline, which might not be so simple to work with. So I'll just right click, explode it, and then delete that segment that we don't need, and start tidying up manually, just dragging and dropping the remainder of these geometry lines. In this particular area, we can see that we've got many geometry lines that have been imported that basically a lot of them don't need to be there. So if we really wanted to, so for example, this one we could delete. We already exploded it. We already have a geometry line here that will be used to define this stair shaft. So really we don't need this one either. So a good rule of thumb is only use one geometry line where one is needed. It just makes the model that little bit simpler to work with when meshing, when cleaning meshing errors. In this case, I haven't been too strict with deleting of the excess geometry lines. Why? Basically, this geometry is relatively simple, predominantly in the orthogonal direction. The next video will go through an example that's pretty much all in the diagonal, and we'll see just, it's much more important for diagonal models to get rid of these excess geometry lines. But for this case, I will just do, I will just keep them as they are. So here we see we have a slight nib modeled. Basically, that's how it might be in reality. One option could be just to pull that back for simplicity or keep it as it is. What I'll do is I'll just simplify the model for this preliminary design case. So I'll just set, oh, I don't even need to use set as master. I can just manually pull it back. And then I can remove this node. Let's just see where this lines up. Okay, that lines up nicely in the center. And then we'll just pull this back to the center line. Here, rather than align those walls, I'll just have a slight angle in that geometry line. That should be okay. And the final thing we need to do is to copy up the ramp slabs from the basement 2 level. So this slab should now be fixed up and the walls aligned. We've got some excess geometry lines, but that is okay. We can use, we could delete them if we wanted to using these tools, but again, I won't do it in this case. This model is relatively simple, but we'll go through them in more detail in the next video. And continuing on the upper floor, we repeat the same process. So I'll just copy the walls up again, just keeping note that we need to pull this single wall back to this intersection. So we select by type. Or what I'll do, I'll just switch everything off, switch on walls above, net select, delete, go down to the floor below, select, control tilde, and hit ground. So we go back to ground, switch everything on again. We had to pull this wall back to this intersection. The perimeter geometry line, this little overrun, it's not doing anything for us structurally, so we can get rid of it. Rather than manually drawing it this time, I will delete, go down to the floor below, select the geometry line, control tilde to copy up, and hit ground. So the perimeter geometry line has been imported. And like we did on the lower floors, we'll just tidy up these lift and stair shaft geometry lines. So this should be all tidied up. It looks like we're missing some geometry lines here. Maybe they didn't import correctly from CAD. So I'll just draw them in manually by hitting G on the keyboard and just fixing that that basically ventilation shaft up. So this should now all be good on the ground floor. And continuing up, basically this will be the final floor that I'll talk about in detail, and yeah, then you're welcome to continue watching how I clean up the upper floors, but sort of this is the last floor that will have the final teaching point for this video. So let's just quickly remesh again. We'll see what the issue is on this floor and we'll see how to fix it up. So we haven't touched the upper floors, we don't want to remesh the entire job, so I'll just hit update mesh, so we'll only generate mesh on the floors that we've changed. Hopefully we don't see any meshing errors on the floors that we fixed, which so far looks good. Great, okay, so no meshing errors on the lower floors, what we did was correct. We'll go ahead and we'll fix up the level 1 slab. So straight away we can see that there are big chunks of this slab where the program is just not generating any finite element mesh at all. Why it wasn't able to generate finite element mesh? The reason being we don't have a single closed form polyline wrapping around the entire perimeter of the slab. So we don't have a single closed form polyline wrapping around the perimeter of the slab, so we'll go ahead and copy the perimeter from the floor below in. Now let's just quickly switch everything off except for the current slabs. So we'll just explode and delete the segments that we don't need, because we do have a diagonal member here. We don't want to have to worry about that later. Similarly with these ones, we'll get rid of them because we're going to be copying it up from the floor below. Same with this one, we will explode and delete. Going down, we to the lower ground, Control tilde to copy up, and we go to level 1. So if we were to mesh this again, we should see that this would mesh nicely. Switching everything back on, this particular area we have some sort of outhouse or some other small structure next to the main structure which we want to model, but it basically is we have walls that stick out past the perimeter of our slab, hence have no vertical support. So what we need to do for these guys is we have to either run them to the lowest level, or we can just segment them and put a footing in. So how we do that, we hit set as master, split wall at master point. Similarly for this wall, split wall at master point, and we'll just pull this back to match the center line here. And we'll just change the footing property of these walls to yes. Now what I've done, when I've set the footing property, I'm putting a Z support underneath, basically an infinitely stiff Z support in the Z direction, so that being up and down the page, underneath these walls. So essentially these walls will not move. In this case I'm happy doing that because all this is going to be supporting is just a single level of roof above this little cabana outhouse thing that's going to be modeled here, this garage possibly. If it was something, if it was supporting a majority of our structure, I'd probably want it running down to the lower level, to the lowest level, just so we could model that elastic shortening of the vertical elements and sort of model a more realistic load distribution within our structure. So those walls are modeled. Now we already have the perimeter slab here. There's no need, we're not really interested in what's going on with this slab here. That'll probably just be slab on ground. It can be modeled in the SLB software if we're going to design it by itself. It's just a square. So I will explode this, get rid of these segments which we don't need, so I won't model a slab on ground, and I'll just pull these back to the center line. And extend and clip. Not there, back to there. So if we switch off everything and just show the walls, we just have this nice segment here. So this area now, obviously there'll still be meshing errors, but we have everything modeled, wrapped around one closed form polyline, and these walls have their vertical supports. This particular wall nib, it might be there in reality, but it's not supporting any structure, so we will just delete it for the time being. Now I'm going to go through, basically that's all I wanted to talk about in terms of principles in this video. I'm going to go through now and clean up all of the upper levels. You're welcome to watch just to see how I do it in this particular case. But basically I'll just provide the summary of the key points, so if you want to move on to the next video, that's fine as well. So summary of the key points is RCB, the key elements are the walls. So we should basically fix the walls once, never have to fix them again. We don't want to be chasing our tail. So starting from the lowest level, we fix the walls and then align everything up to them, being other walls, geometry lines, columns, if needed as well, to the wall elements. So important thing to note, wall elements are the key elements because they're meshed to above and below a certain floor, and they're also the basically they're the most complex element in the software, hence they're the element that can cause the most errors during the analysis. So we have to be very, very careful when modeling the walls. We recommend rounding off your geometry to 1 or 2 decimal places all the time, regardless of the orientation of the slab, be it orthogonal or diagonal, and basically sticking to that degree of accuracy, then cleaning up the meshing errors. So even in the preliminary design stage, it's going to be quicker to round off and clean up the model than it is to stick to a high degree of accuracy and just sort of try to push on through all of these meshing errors and analysis errors. And finally, other key points that were touched upon weren't really practiced in this video because it's relatively simple. Using one geometry line where one geometry line is needed to define a flooded area, unless the geometry is relatively simple, like in this case, it's where it's all orthogonal, but that will be discussed in depth in the next video. So basically that's the end of this video. You're welcome to keep watching me clean up all of the upper floors just to see how this cleaning up works, to see how to do it as quickly as possible. And yeah, that's it. This concludes this video. Thank you for watching.